Okay, class, so there's two main things that I wanted to finish up with respect to the phylum Annelida. And recall that the annelids have two major classes. There's the class Polychaete, or the Polychaetes, and the class Clitellata, which includes two subclasses, the Oligochaetes and the Hybridinians. All right, so the two pieces that I want to do is, we talked a lot about the Clitellatas already, and we also talked a bit about many of the features of the Polychaetes, but what I didn't get to yet is reproduction in the Polychaetes. So two things I'm going to do in this online lecture is to talk about reproduction in the Polychaetes, and also to talk about some really special Polychaetes that live in near the deep thermal vents in the abyss of the ocean. So those are our two goals for this online lecture. One of the things about Polychaetes that differentiates them from the Clitellata, especially the Oligochaetes, is the fact that they're dioecious instead of monoecious, right? So we remember this word, meaning that the sexes are separate, and we're going to see where the individuals are modified in terms of either being male or female. So one of the first things to note about Polychaetes is that they actually can undergo asexual reproduction and regeneration. They have pretty strong powers of regeneration. And so they can bud off individuals that may just be identical and therefore be asexual reproduction, right? Remember we talked about in class how there's lots of different ways of asexually reproducing, and if you bud off genetically identical individuals, then you've reproduced asexually. So the Polychaetes have this really interesting process for sexual reproduction called epitope. And what epitope is that individual Polychaetes will transform into something called an epitope, okay? And what an epitope is an individual that is sexually mature, and it's either male or female, and they're highly specialized for both swimming and sexual reproduction, okay? And so epitope can involve asexual budding. Okay, so individuals can bud off these sexual epitopes. So epitopes are budded off one segment at a time from the posterior end of the animal, okay, which will stay behind in a tube if you're talking about a sedentary polychaete. Okay, so now the original individual that stays behind is now referred to as the atoke. Okay, so you have an atoke, and here in this diagram you can see that the epitopes are still attached. And in some cases the atoke and the epitopes will stay attached to the whole worm as they swim off and the epitopes release gametes. And again, in other individuals, the epitopes are budded off, okay, and so they'll go off and swim, and they're no longer attached to the atoke. In both of these pictures, it shows them still attached. Okay. Now, so recall that Polychaetes are dioecious. And so what happens is, unlike Oligochaetes that have distinct gonads, Polychaetes don't have any gonads. You don't see ovaries, you don't see testes. But instead, the gametes are produced from the peritoneal tissue, okay? And they're released into coelomic compartments, all right? Remember that the coelom, and that annelids are true coelomates, is divided into these different compartments because of the segmentation or the metamerism that annelids show, right? So the peritoneal tissue, or the peritoneum, is that tissue that surrounds the coelom. It's mesodermally derived, right? And it's this tissue that the gametes are produced from and then released into these coelomic compartments, okay? On this slide we can see other examples of epitope in some different kinds of Polychaetes. And what you can really see is that there can be quite a bit of differentiation in terms of how epitope is accomplished. It's the size of the epitopes, the way that they're budded, and again, whether or not you have a sedentary polychaete versus an errant polychaete, right? You should remember what the difference between those two are. And so, again, the atoke is going to be left behind in a burrow or a tube if it's sedentary, and the epitokes are going to break off whether they're male or female. And again, individual worms are only going to bud males if they're male, and they're only going to bud females if they're female. So those epitokes are going to break off and swim away to accomplish sexual reproduction. This is showing a Nereus epitoke, which is an errant polychaete, and so the atoke is probably still present here. But regardless, you get the idea. You have this specialized individual. It's swimming around, and what's really fascinating is that in some species of polychaetes, they will have they'll show bioluminescence at the time of sexual reproduction. When I take my marine biology class to the Turks and Caicos Islands, we have this really special opportunity to observe a polychaete called Odontocylus anopla, which is also known as the glowworm. Sometimes you'll see it called the Bermuda glowworm or the glowworm from some other places, but they definitely occur around the island of Providenciales where we take our trip. And you'll see them 3 days before up till 3 days or so after the full moon, which is pretty neat, undergoing sexual reproduction via epitoke. And so this is what the worm looks like many other polychaetes, except they can bioluminesce. And what isn't pictured here is actually it's the epitokes that are bioluminescing, right? So what happens is the female will begin to glow really, really brightly. And then the males, which are a bit smaller but also bioluminescent, will through chemical senses will both through visual and chemical senses. So he'll see the female glow, and there's also these chemicals that she's producing so that the males know that she's there. And this happens all very quickly. So the female starts to glow, and then the males come in from everywhere in this 360-degree angle, just start dive bombing this female. And of course, she's shedding gametes at the time that she's glowing. So she's glowing, shedding eggs into the water, and then the males are dive bombing in as quickly as they can, because of course the first males that get there and shed their sperm are going to be able to fertilize a greater number of these eggs. And so selection has led towards this very unique behavior. And it's just beautiful to see, because you'll have females will start to glow over here, and then the males start dive bombing over here, then another female will start to glow over here, and the males come in over here, and then another female will start to glow over here, and the males come in. And it happens very rapidly, and it's really quite spectacular in the water. And it's such a phenomena that they even have devoted sailboat cruises that they call glowworm cruises, that if you go out just around the full moon, just before and just after, they guarantee that you'll see this fireworks display, as they call it, in the water. And it's really these polychaete annelids that are doing this beautiful example of external fertilization via epitokous reproduction. Just a couple of other epitokes to show you. Psyllid is short for Psyllidae, which is a family of sedentary polychaetes. So again, we have just an epitoke here, not attached to the atoke anymore. Same thing with this individual over here. Okay. Remember that annelids have Trochaphor larvae, which is an important synapomorphy that ties them to the mollusks, which we're going to be talking about pretty soon. This is just to show that after fertilization, the zygote develops into an embryo, the embryo develops into a larvae. It's a Trochaphor larvae, which is a feeding larvae. Again, some larvae feed, some don't. We haven't gone into the details of all the larvae that much yet. And then you can start to see during development, it'll start to segment and start to produce that characteristic segmented body of an annelid worm.